Welcome to all of you. Thanks a lot for being here. Very crowded assistance. I'm really happy to hear it. Today we have Kirsten Haggart that is here with us from Waugh Thistleton Architects. And she will be here mostly speaking about the activity of companies and how they are embracing sustainability from the beginning of the project, and how this also leads them to use timber as a main construction material. And I was really happy to invite Kirsten to this design festival, because while I was making some research for my class on timber construction to try to introduce timber construction to students, I came across a lot from building from Waugh Thistleton. So inviting someone from the firm for this event seems very natural for me, because the theme of this festival is shaking boundaries. And this morning you have heard about shaking boundaries as a way of physically shaking the boundaries. But this will be more about how to think differently, how to think that there is other ways of building than just using reinforced concrete column beams and infill with bricks. And this is exactly how Waugh Thistleton is working with timber, working with different type of timber for different type of construction, and not only using timber, but really checking buildings from the beginning, which material will be the more interesting, which energy system will be the more interesting. So I'm really happy to have someone to show you that it is possible to do architecture in this way, even as a very large scale. So thanks a lot, Kirsten, for being here and showing it to us today. You are an associate director at Waugh Thistleton, and with over 20 years of design experience and working across sector in the office. And Waugh Thistleton have been one of the leading firm in the zero carbon architecture, incorporating low energy design and innovative construction method into buildings. So that's what is really interesting for us, and we are really happy to see it. Moreover, Waugh Thistleton were shortlisted for the Rebar Stealing Prize in 2018 and won the Architects Journal Practice of the Year in 2023. So all of this made us really happy for you to be here. So thanks a lot, and please, you can continue.
Hello, everyone. Nice to see you all, and it's great to be able to talk to you today about our work. So I'm just going to share the screen. So we are Waugh Thistleton Architects. We are based in London, and are a practice of around 25 people. We've been championing sustainability for over 20 years now. And one of the key drivers behind that is obviously to do with climate change, which is becoming more and more impactful on us all, as we've experienced with over recent years. Our approach is very much around three main things, really. We take a very integrated approach in the way that we design our buildings. So involving sustainability consultants, structural engineers, services engineers in that early stage of a project is so important when we're thinking about sustainability and efficiency and sufficiency of the way that we build. We do a lot of research, and so the innovation that we develop is also done through research. We've got a couple of Euro Horizon 2020 funded projects where we're working across the whole of Europe with lots of partners to feed into the development of the way that we design, and a couple of projects, one of which is called Building Wood, and I'll show you a bit of that during the presentation. And then obviously we're designing for people. That's ultimately the goal. And the way that we approach our architecture is really to ensure the well-being and health of those who are going to be using the buildings. We work across different typologies, from residential, commercial, and religious. This is the one that we were nominated for a Sterling Prize for, the one on the right here, which uses rammed earth. And I was learning earlier that that is a traditional material for Turkey. We worked with some Australian contractors to develop this rammed earth building, and it's a crematorium, actually. Oh, no, a cemetery, sorry. And so the idea of the building being made from the earth was very poetic in that case. We work with lots of different clients, big and small, as well as working and collaborating with universities, including the University of Cambridge. So as I mentioned, climate change is a very real and pressing issue, and something that we're simply not doing enough about. And I think as individuals, we can often feel that we don't have a lot of agency in what we're in addressing climate change. We don't have a lot of power to change it. But actually, as architects, we do have a lot of influence, and the way that we design and build our buildings is crucial to mitigating the impacts of climate change. And that's because in construction, in the actual materials that we use to build buildings, it accounts for 11% of all global carbon emissions across the world. If you include the energy that we use in buildings, that goes up to about 30% of all carbon emissions. So as architects, this is a huge impact that we can make in the way that we design our buildings. Concrete and steel are huge emitters, and that's partially the reason why there is such a large quantity of carbon emissions through construction. Yeah, concrete, obviously a material that you're all familiar with, but it does use a lot of energy in its production, as does steel. So we've, as a practice, have been trying to think of ways that we could balance that. We could try and offset or remove as much concrete or steel from our buildings and replace it with more bio-based materials. And this slide just highlights the progress that has been made, certainly in the UK, around energy in use. So the amount of energy that the building uses over its lifetime, that can be offset with renewable energy, decarbonisation of the grid, as well as using low energy light bulbs and that kind of thing. So the systems that we put into our buildings can also reduce the amount of energy that we use in them. Embodied carbon, which is the carbon that is within the structure and the fabric of the building. That's only recently in the UK, probably in the last 5 years, just started pre-pandemic really, where we started to think about that oh, we need to think about how much the materials that we're specifying for the buildings that we're using, how much energy they use. And one way to think about that is either to offset the energy that's used to manufacture those products, or you can think about sequestered carbon, which is which occurs in bio-based materials. So it's the carbon that a material can store. And I don't know if you're familiar with this, and it might be a bit too detailed for this lecture, but it's something that will be coming your way. It's called a life cycle assessment. And in the EU, they are starting to mandate life cycle assessments for all buildings. So what that means is that we're going to need to measure and log and report on the amount of carbon and in a building when we are when it goes to planning. So in this I would encourage you to kind of look at this to study a life cycle assessment, because there are a number of different factors which I'm going to go through in the presentation that we need to think about when we're designing. So in terms of this A1 to A3, this is the raw material supply, the transport and the manufacturing carbon in a building. Then it's A4 to A5 is the transport and the construction installation carbon, so the energy used to transport all the materials to site, and then the energy that's used to kind of put them in place when they're being built. And then we've got the B section, which is all about the energy and the carbon that's used to maintain, repair, refurbish and replace aspects of a building. So over a building's lifetime, the systems that are used for heating and cooling might need replacing. We might need to replace some of the linings, those sorts of things. And then operational use, which I think we're all quite familiar with, and also water use is also a big factor that we need to consider. Water poverty potentially going to be an issue in the future. And then the end of life, and how we can either take the building apart and dispose of it. You know, what are the outcomes for that? And then, if possible, how do we recycle the materials that we put into the building right at the beginning? And one of the research projects we're doing at the moment looks at how you could reuse timber from existing buildings. So it's another EU funded project. It's something that's also coming down the line. So I'm just going to break down the way that we think about the way we design into these very simplistic 4 categories. But hopefully this will help you when you're thinking about designing your buildings to think in a slightly different way. So I've categorized it into materials, massing, MMC, which is modern methods of construction, and demountability, which is that last section of that life cycle assessment. So first of all, materials. So when we think about the embodied carbon and the carbon that is that we use when we're designing our buildings and specifying them, the biggest portion of where the carbon emissions would come from is in the structure. But also something that's becoming much more prevalent here is thinking about retrofit, how we can reuse what we've already got and extend it, and to extend the life of those buildings. So we're not actually using any new materials. You know, ultimately, a sustainable way of designing is to kind of think about how little you can actually use. But if we're designing for a new building, then this is a really good starting point in terms of how we perceive and understand the embodied carbon of materials. This is called the material pyramid. It was developed by Copenhagen Royal Copenhagen School for Architecture and a company called Van Kunsten. It's actually an interactive tool. So if you look it up online, it's really, really helpful for you to be able to assess the embodied carbon and the impacts that different materials have on your specification. So at the bottom here, it's a bit like the food pyramid. You've got the low embodied carbon materials at the bottom. These typically are bio-based, so timber and straw and things like that. And then at the top here, we've got high embodied carbon materials such as aluminium. And in the middle, there's kind of glass and brick and those sorts of things. And I think what's important to mention here is that it's not about using all the materials that are down at the bottom of the pyramid, because we want to make sure that the building has a long life as well. So protecting it using flashings and roofing materials and things like that is so important if we do it efficiently and sufficiently. So it's about using the right materials in the right locations and not using materials just for their own sake. And when we're looking at alternatives to concrete and steel, we have in the past have used and continue to use cross-laminated timber, which is short name is CLT, and it's like really thick plywood, if you know what plywood is, and it's basically planks of timber that are laid in one direction and then the other, and they're glued together. So it's really jumbo plywood. Glulam is used typically for columns and beams, and then we've got laminated veneer lumber, which is LVL, and that is that's where they take a log and they peel it essentially, and then you get very thin layers which you then glue together. And LVL is a material that is much stronger in its, so for the same section size, you get much more strength than you do for glulam, but it is more expensive, so just to bear that in mind. But we've used, and hopefully I can show you some examples of all of these and where we've used them. So when we're thinking about embodied carbon of buildings with different structures, reinforced concrete is a really big emitter. You can use low carbon concrete, but and that it has some recycled elements in it, but I think it's a bit overstated how much of that recycled element you can actually use in low carbon concrete. So be careful when you're specifying that to make sure that it can be actually sourced and procured and bought. And then timber is a much lower carbon footprint. And then if you include the carbon stored within the timber, so trees, when they grow, they absorb CO2 and they store carbon, give off oxygen. That's what that means. It's the carbon that is stored within the fabric of the timber, and then you get down to very, very low levels here. So I'm going to start with one of the first projects we worked on using CLT, which was one of the tallest timber CLT buildings at the time, residential project, where we designed 29 homes in central London. You can see it's a very urban built-up site. And this was made out of CLT platform construction. So you can see here how that manifests itself. So essentially what you have is we had a concrete plinth in this project with CLT walls, then a CLT floor, and then walls again. And so it all just stacks up a big, like a big honeycomb essentially. And then you line out all the interior with plasterboard for fire and acoustic protection. But this whole building was built in 8 weeks. And what happens is all the windows and doors and everything are all cut out. They're pre-manufactured in the factory as large panels, and then they come to site with all the doors, the services, penetrations, the windows, all pre-cut. And this is what it looks like internally when it's being built. And it's a really simple form of construction where you have these angle brackets that connect the floor to the wall. And it's really simple for then installing services and things because you can just drill into it. So because it's made off-site and because they're large panels, you have way less waste than you would in a conventional build where you have stud partitions or lots of different elements coming together onto site. This is a much simpler way of building. There are a lot fewer deliveries to site as well, and that also reduces the amount of carbon emissions to the development, and the foundations are much less than they would be if it was a concrete building, because the timber is much more lightweight than concrete. So your foundations are a fifth of what it would have otherwise been. And it's incredibly quiet to build as well, and quick. So the residents are not disturbed either. Oh, so now I'm going to touch on the next residential project that we worked on, which is quite substantially bigger. This was called Dalston Works. It's 121 homes, 35,000 square feet of commercial space. And it was, again, one of the largest CLT buildings that was that's been built in terms of residential. And in this case, there was a real benefit to using timber because we were in the, there's a route, a rail route that goes across London that has got a designation zone called HS2. And so you couldn't use piled foundations for this project. So we were able, because it was CLT and it was very lightweight, we were able to use a raft foundation for the whole project. And also because it was quite lightweight, we could put more homes on the site, which in London is incredibly valuable because land prices are so high. And in this case, unlike in the Murray Grove project, we really learned about the efficiency of the material. So we looked at how we could, so in Murray Grove, all the walls were all the same thickness the whole way up the building. But as you can imagine, the higher up the building you get, the loads, the weight of the building is not as great. So then you can have now thinner walls to support it. So in this case, we were able to apply a slightly different technique in that we used this donut construction, which provided the main stability, and then internal walls were much thinner than we'd previously used. And also, as you went up the building, the walls got thinner to reflect that change in the load requirements. So this is it completed. And again, in this project, the use of timber, not only was it a really sustainable approach, but also it allowed us to deliver more homes. Again, we had fewer deliveries to site, which, as I mentioned, in an inner city environment is really beneficial. And this is an interesting fact, is that the Austrian forest, where the trees grew to make the CLT, because of the quantity of timber and trees in that forest, it only took 3 hours for the timber in this building to grow. And it was around about 2,325 trees. But as trees grow older, they stop absorbing carbon in the same way as they do when they're younger. So when they get to about 60, the amount of sequestered carbon goes down in the timber. So it is actually a good process and kind of a very sustainable process to cut down selected trees that are older and use them in construction, because it means that you're storing that carbon away. This is an example of a retrofit project. I thought I would just show you this, as it's something that I think is going to become increasingly important going forward. So in this case, we took an existing, the grey concrete frame here is an existing 70s office building, and we stripped it back and then added a CLT extension and to the roof and to the rear of the building where there was a car park. So we've added 7,000 square meters of extra office space. And also applied some very clear environmental techniques to this. So it's naturally ventilated through this central atrium space. And so you get really good cross ventilation through the project. And you can see here the vents in the offices that vent out into this space. We've also got a kind of cantilevered CLT staircase, and this was really part of the main brief, which it was for a company called Ethical Property, who encourage small businesses to work in the same environment with similar kind of social value principles, and they wanted them to be able to interact and socialize within this main atrium space. So the kitchens are just around the corner here, and you get this really lovely kind of flow of people through the space, as well as the natural ventilation benefits. So in terms of embodied carbon, by using the existing building and extending in timber, we saved 2,200 tons of CO2 by taking this approach. And this was, quite groundbreaking at the time. So now I'm going to touch a little bit on massing and how important the massing of a building and a master plan is in terms of both reducing the energy in use and also the embodied carbon of a project. So this is a project called Trinizia we did in Bergen in 2019. The client wanted us to propose essentially a village on a lake. The lake was quite polluted, and around Bergen there are about 7 mountains, and lots of people were moving out of the city, and they wanted to kind of devise a way of keeping people and retaining the kind of vibrancy of the city centre. So we came up with a proposal for a kind of Venice of the north up in Bergen in Norway. And principles behind the way we developed the massing were really fundamental to the overall final design. We looked at the wind direction, which actually changed in winter and summer, so that has an impact on natural ventilation and things like that. And then this idea around solar corridors, which was really key to the way that we developed the master plan. And this in Norway, if you take north and then you go 30 degrees east and west, and you develop these things called solar corridors, so routes through the master plan at those sorts of angles, then you're optimizing the amount of daylight and sunlight you get as the sun crosses over the sky throughout the day. And then obviously where you've got buildings to the south and you've got courtyards between, it's a really good idea to kind of keep the height low as possible to the south and then build it up to the north, so that these interstitial spaces become really beautiful and well lit. So this is the master plan overall as we developed it. So you can see here to the south, there's the more residential, smaller blocks, particularly down here. This is south facing, and then it builds up to the north, and then towards the back here we've got the taller towers, which are also residential but with some commercial. And then these routes through where we have the canals, they reflect the solar corridor orientation, as well as vehicular routes that go in this direction as well. So this meant that the energy load within the buildings, within these residential units, was much less, because you'd need less lighting and heating, and also you minimizing the amount of cooling that you need as well. And the spaces between the residential blocks were also optimized for daylight. And we also used the city was developing some like tunnels and a railway network through the tunnels, through the mountains. And we were able to propose that the spoil from those tunnel excavations could be used for the foundations. And here's some views of what that might look and feel like. This is the boardwalk, the real social space that links both sides of the lake. And that's it at dusk. And then just moving on to modern methods of construction and off-site manufacture. So we know over the last over 100 years now that the development of the car industry, for example, and other methods of construction where you've got quite a lot of repetition. I mean, that is a key factor in the way that this becomes more efficient. But the automation of the manufacture of cars has become incredibly sophisticated. And the way that that has been developed is that you kind of have this kind of chassis, you have various components of the whole project, of the whole car, that are made by different manufacturers, and then it all comes together on an assembly line. And the holy grail really for construction, and I think now that digitalization of the way that we design and BIM modeling and has become, you know, second nature essentially, that's becoming more and more sophisticated. So we can start to think about digital twins for buildings, which also helps us in terms of that end of life piece for how we demount and maintain buildings throughout their lives. Because once we've got a record of exactly what's going into that building, then it's much easier to then identify how we can efficiently replace elements of it. But also it becomes a case where the building site becomes the assembly line, where you can have components that are manufactured off site and brought together in a much simpler way with a lot less waste. So as I mentioned before, we've got this project called Build in Wood, which is a Horizon funded project. This is one of our research projects, which has sort of informed a lot of the way that we approach a number of our projects since having done this. So this was a project where the EU tasked us with designing a system that could be used for residential, commercial and retrofit. It needed to adapt to every different regulation requirement across Europe, which was quite challenging, and could be applied to different markets across Europe. It also needed to be optimized for the use of timber. It could be reused and disassembled and taken apart at the end of life. And it was also had to be very resource efficient. So we looked at two aspects, the structure and the facade, and came up with a post and beam system for this, which could be used in different ways and for different spans. And then we also had a facade system which could be adapted to the different thermal acoustic requirements across Europe as well. So it became a 3-layer system. We'd also did lots of testing for moisture and acoustics and fire as part of the project, sort of addressing some of the challenges that people perceive. And I think rather than going into that now, there are solutions for all of these things that are out there. And we looked at the demountability and how the connections worked, working with a company called Rothablas, who do a lot of the timber connections for timber. And again, parametric and DFMA, design for manufacture and assembly, were all fundamental to the way that we approached the project. So we developed a parametric tool that could adapt the structural member sizes depending on the spans that the system and the building required. And again, this could work for commercial, residential, and roof extensions and retrofit. And it essentially was a very simple kit of parts that could be deployed in lots of different circumstances. We applied this way of thinking to the Mind Milan project that we did with Lend-Lease. So Lend-Lease are a massive developer and contractor, and they've got this site in Milan, which is 1 million square meters. And in order to make this as efficient and sustainable as possible, they tasked us with coming up with a system approach to the way that they could design the residential and the commercial buildings. This is the project that we ended up designing for them, but the system was applied across the site. And so essentially this was a post and beam, very similar to the build-in wood project that I just described. Post and beam system, we have this route, and this is really important in terms of adaptability of buildings. We have this route for services that comes directly next to the core that can be distributed into these bays. And that means that the services distribution is incredibly flexible. And those principles were then applied across the height of the building. We also had a off-site manufactured facade panel that we could use. This gives you a sense of what the interior of the reception area would be like with a CLT staircase and these large, these were glulam beams and columns with a rib deck floor plate. And that's the render of it when it was completed or when it went to planning. But you can see these louvers here as well. This was very important in terms of the solar radiation on the building, that we developed a louver system which changed as it went around the building so that you were minimizing the overheating. Another project where we applied very similar principles was the Vitsu factory that we designed back in 2018. And this was for a client who had a shelving system, which was very much a kit of parts. And what the client really wanted us to apply similar principles to the way that the building was designed. And so we came up with this idea of a bay using an LVL, laminated veneer lumber frame here, with CLT floor plates and roof and facade panels, as well as prefabricated glazing units. And originally this was designed as 10 bays, but then it extended out, I think, to 21 in the end. This is it on site, just as it's topping out. And in terms of the interior, you can see how beautiful the timber makes the space feel. And this is one of the key. It's anecdotal at the moment, but there's lots of research at the moment about the well-being and health benefits of living in and working in bio-based buildings and how it can reduce stress levels. But again, here we've been very careful with the way that the services are integrated so that it's very easy to adapt this building if you need to. You can introduce mezzanine levels, extra offices. You could have an office above this shop area there. So it's extremely flexible as well. And finally, demountability, just as a concept, I think is something we don't, it's becoming more and more in vogue, I suppose you could say, but also important for the way that we perceive our buildings, and also in terms of minimizing waste. So there's this concept that actually all our built environment is a material store, and that we should be mining the built environment for materials to be able to build new buildings as other ones are taken apart. So I'm going to touch on a couple of projects. First one is Orsman Road. This is also in London. If you come and visit us over here, we can do a little tour of all our projects. They're all about, most of them are within a short radius of the office. This is about 5,000 square meters. It's on the canal. This one is interesting because it's a hybrid of CLT and steel. Steel is, although it takes a lot of energy to manufacture, it is actually quite easy to reuse and demount at the end of life if you use appropriate connections. And in this case, the client demanded that we had a much bigger span than was efficient to use timber. So it's also horses for courses. And what we're finding is that it's important to bring your client on the journey. If they want to go down the journey of a all timber building, then the grid needs to adapt to that material. So you end up with probably smaller, up to about 7.5 meter, 6 to 7.5 meter grids, and you need to be very careful about how you're using different CLT panels. Make sure you're designing to optimize the use of that, so you don't cut the panels as much or very much at all. And so in this case, it was designed for disassembly, and you can see here this is the build-up of the material and the section. So we've got a steel castellated beam with CLT floor plates and walls, and then it's also clad in a very lightweight material, so that you're not adding to the load of the building and thereby increasing the structural member sizes. This is it in construction along the canal. And here you can see one of the interior shots. We've used clay plaster on the interior, which is a breathable plaster. And it's a really conscious decision to expose all the services in this case, because that means it's really easy to maintain. And also you're not adding extra layers of plasterboard and material, which adds to the carbon footprint of the building. So again, it's all about being very sufficient and efficient with the materials that you're choosing and being really conscious about that. And in this case, we were able to adapt the layout of the building by introducing this staircase. It was a requirement that the client asked for after the building was completed, and we took out the CLT floor plate and were quite easily were able to install a new staircase using the CLT that we'd cut out to make the landings and the treads. And I think that's something that, you know, this adaptability aspect of design is something we need to be very careful about. And that would be, to do that in concrete, reinforced concrete, would be incredibly difficult. And finally, I'm just going to touch on the last project that we have completed, which was completed at the end of 2022, the black and white building, which won an AJ award for commercial. It's been recognised, I think, across the world as being one of the most innovative and sustainable office buildings. And so this is 4,500 square meters. And again, this idea that the Austrian forest only takes 52 minutes to grow the timber that's in the project is quite a compelling statistic. So we applied all the learnings that we'd had from the previous projects and developed this kit of parts for For the project, it's an LVL post and beam system with a CLT floor plates. It has a timber curtain walling system and has tulip wood cladding on the exterior. And all the connections are bolted, so you can really easily take the whole thing apart at the end of life. The way that the facade was designed was using parametric tools to assess the sun and the radiation on the facade, and then the depth of the louvers were adjusted to suit the level of radiation. So the deeper the louvers, the more radiation that part of the facade had. So you can see here the upper levels of the facade have much deeper louvers than the lower ones, and actually to the south we've got horizontal louvers instead of vertical, because that's more efficient at reducing the solar impact. We had to have a basement for the project because of various planning requirements for cycle parking, etc. But we're really championing at the moment no basements at all if we can avoid them, because they are huge carbon sinks. And then the rest of the building took 14 weeks to build, so you can see the benefits there. And in terms of the embodied carbon of the project, when you include the sequestered carbon, we're actually a third less carbon than if the whole building was built out of concrete. And they're huge, differences, as I said at the beginning, that impact actually has very tangible benefits in terms of the environment. And if we start to be thinking in this way across all the built environment, then we could be making some pretty major changes. And just some slides to show how simple and easy it is to put together. So these are the steel plates that were specifically designed for the connection details, and then you bolt the timber into the plates. And you can see as well, I'm sure the simplicity of this makes it very easy to take apart, and it's really easy to construct. So this took about 5 guys as well on site. Really simple but beautiful detailing. And this is it. We worked with a local interior designer as well, who shared a lot of our values and principles, who sourced all the interior fit out from local sources and local manufacturers. And I think you'll agree it creates this very beautiful, warm and biophilic environment. And the reports so far, it's only been open a year, is that people are really thriving in this building. So thank you very much. I hope that's a bit of a whirlwind tour of all our projects, but I hope it gives you some thoughts about how you might approach some of your projects going forward in a slightly different way.
Thanks a lot, Kirsten.
Thank you.
So thanks a lot for this presentation. It was really great to hear and to see all the details on those buildings, the construction details, or the amount of carbon saved due to the different solutions. So before finishing, I would like to share my screen with you. Here it is. Can you see? Could you see my screen, Kirsten?
Sorry, I'll just stop sharing.
Yeah.
Oh, yes, thank you.
Yeah, so the university would like to tell you that a sampling of a tree has been planted in the university forest at your name. So to thank you for your intervention to your speech. So thanks a lot again for being.
Thank you.
So
that's lovely. Thank you. I'm getting quite a little forest, actually. I often get given a tree for doing a talk. It's nice.
So thanks a lot for everything. We will send you this document by mail also. So
okay.
Thanks for everything.
And I can share the present. Well, you've got it recorded, haven't you? So people can hopefully, can re-look at it. Thank you. Take care. Have a good day.
You too. Bye-bye.
Bye.